So yesterday we looked at area, and that is used if you have a two-dimensional shape, like something that is just drawn on a paper, or you can find the area of the top of your desk, area of a piece of paper, or an area of a shape that, again, is drawn on a page. And we looked at the different area formulas yesterday, and they are on your formula sheet. So now we're going to jump to surface area that is used for three-dimensional objects. The surface area is the area of all the faces added up. It's the area of all the pieces that you can see. You could pick it up, you could look at the bottom, you could look at the top, look at all the sides. You're going to find the area of all those pieces added up. And one strategy that we can use in order to find surface area is to draw what's known as a net. A net is what you would get if you took the shape and you cut it apart and laid all the pieces down flat on a desk or on a page. All right, so we go from a three-dimensional to a two-dimensional. So the bottom row are the shapes, the top row would be the nets. So this first shape is a pyramid. Okay, it has a base that is either square or rectangular, but the sides are all triangular. So the net that matches with that pyramid would be the second net. It's got a square or rectangular base, and it's got four triangular faces. This next shape is a cone. A cone has a circular base and rounded sides. And the net that would match that would be the last one on the top. Notice that a cone has a slant height. It's the length along the edge of the cone. That's different than the height, which is from the very tip, the vertex, straight down to the base. That's the height. But cones have a slant height. And so the bottom is a circle, excuse me. So you can see this net has a circle. And then if you look at the other part of the net, it looks like a big piece of pie. That's what the rounded side of a cone would look like if you cut it apart and laid it down flat. The next 3D shape we have is a cylinder. A cylinder has a circular top and bottom and rounded sides. So that matches the first net at the top. You can see it's got a circular top and a circular bottom, just like the cylinder has a circular top and a circular bottom. But notice if you took the side of the cylinder and you cut it apart and laid it flat, it's actually a large rectangle. And so then this last one, known as a prism is a 3D shape where it has faces that are square or rectangle. There are 6 of them, and this would be the corresponding net for that. 6 rectangles or a combination of rectangles and squares. All right, so sometimes we can use these nets to help us determine the surface area of a shape. You would find the area of all the pieces and add them up. That's one strategy. So we've talked about some of these definitions already. It says match each word with its definition. The first definition is a 3D object with a circular base and a curved lateral surface that extends from the base to the vertex. This is what a cone is. It has a circular base and the curved lateral surface. Okay, if we skip down to this next one, a round ball-shaped object, that is a sphere. A sphere is a ball. The only difference is that it's three-dimensional. Okay, that's what makes it different than a circle. Let's skip down to the last one, a 3D object with one base and the same number of triangular faces as there are sides on the base. Well, that's the pyramid that we looked at on that first page. It has a base, it can be square or rectangular, but the faces are all triangles. So the last 2 definitions that we have, the shortest lateral distance from the base of a cone or a pyramid to its highest point. So you can see we have three things to choose from. The one that'll work here is the slant height. So again, if we look over at a pyramid has a slant height. It's the shortest distance from the top down to the base. And same thing with a cone. It has a slant height. It's the shortest distance from the top along the sides down to the base. So they both have slant heights. And that's the definition of a slant height. Lateral distance would be different than vertical distance. Vertical would be straight up and down. Lateral's on a side. And so the last thing is the highest point of a pyramid. Well, if we look at our picture on the previous page, it doesn't have the tip of the pyramid labeled. The tip of the cone, though, was labeled as the vertex. In the case of a pyramid, though, it would be an apex, the highest point of the pyramid. So we can go back to this pyramid here and label this part here as the apex, the very tip of it. Okay, so those are just some key terms that we'll be talking about as we go through this chapter. So this next one, we've got a cone, and we want to label the following 3D object and its net. Okay, and its net. Well, the base is circular. So this would be the base. It's a circular shape. And it has a radius. The radius is a distance from the middle to the outside of the circle. Remember that the slant height is the lateral distance from the tip down to the base. Okay. The area of the rounded part, the top of the cone, is known as the lateral area. And remember, the vertex is at the very tip. And I guess we could leave the radius over here, or we could put it down here for that piece. It doesn't matter. Talking about the same thing. Okay, so those are some of the key terms involved with a cone. So now we're going to look at actual surface areas of these shapes. So the first object is a prism. It has a combination of square and or rectangular faces, and there are 6 of them. So if we erase what's covered up, we can see what the formula is. The first term is twice length times width. Well, length times width will give you the area of the bottom of the prism. But there's a top piece that is identical. That's why it's 2 times length times width. The second term is twice length times height. You see, length times height would give you the area of the front face of the prism. But there's a piece on the back that is identical. That's why it's 2 times L times H. And twice W times H. W times H would be the right side of this prism, but the left side is identical. That's why it's twice width times height. You can simplify this formula a little bit by taking out a common factor of 2. That'll give you LW plus LH plus WH. So there's a variation of the formula for surface area of a prism that's been factored. It does make it a little simpler. Right, and this formula is, excuse me, on the formula sheet. It does say twice LW plus LH plus plus WH. So that's the formula that's on your formula sheet if you look on there right now. SA prism. It's in the middle on the right-hand side. It says SA for surface area of a prism. 2 times, in brackets, LW plus LH plus WH. So that's that formula. The second formula will be the surface area of a cylinder. Remember, a cylinder's got circular top and bottom. So if we erase this, it's 2 pi r squared. And remember, the area of a circle is pi r squared. The reason there's a 2 in front is because a cylinder has a circular top and a circular bottom. There's 2 of them. That's where the 2 part comes from. So that means the 2 pi rh part will be from the rounded side of the cylinder. And it's important to understand where the different pieces of the formula come from, because you might see a cylinder that doesn't have a top, only a bottom. So then you'd have to adjust this formula. Instead of 2 pi r squared, it would be 1 pi r squared. So again, it's important to know what these formulas, where they come from. And once again, we could factor this equation, taking out a common factor of 2 pi r, leaves us with r plus h. Excuse me. So that's a simplified one that we can use. But the first one, 2 pi r squared plus 2 pi rh, that is what's on your formula sheet, Keen. Emery, give him a little tap. Okay, that first one is the one that's on your formula sheet if you look. Surface area of a cylinder. So the next one is a pyramid. So that's the original formula. The first part, length times width, comes from the length and width of the base. It's either square or rectangular. Then you've got 2 sets of triangular faces. The front and the back have a base of L and a slant height. But there's 2 of them, front and back. That's where the 2 comes from. And the 1/2 L times S1, well, that's from the formula for area of a triangle. Base times height divided by 2, or base times height times 1/2. The base of this is L, and S sub 1 would be the slant height. And then the left and right side have a base of W. There's 2 triangles, one on the left, one on the right. They both have a base of W and a slant height, which is slant height 2. Now, 2 times 1/2 is 1. So we can simplify this a little bit and say that it is LW plus, again, 2 times 1/2 is 1 LS1 plus 2 times 1/2 is 1 W times S sub 2. And again, S sub 1 and S sub 2 are your slant heights that come off of those sides, those pieces of the base. And this formula that we just wrote down is the one that's on your formula sheet. If you look, that's the one that's on your formula sheet, the one you'll be given for any quizzes or tests. All right, the next shape is a cone. And there's the formula for surface area of a cone. It has 2 terms. The first term is pi r squared. Where does that come from, Brock? Stay with us, okay? Where does pi r squared come from, Liam? That's right. That's the formula for area of a circle. And a cone has a circular base. So that means the pi rs part will be the area of the rounded side, the lateral area of a cone. And once again, we can factor this, take out a common factor of pi r, and you're left with r plus s if you factor it. But the original one, pi r squared plus pi rs, that's the one that's on your formula sheet if you look. The last one is a sphere. That's a ball. And the formula for surface area of a sphere is just 4 pi r squared. R is the radius of the sphere. That's how you find the surface area of a ball And that formula, again, is on your formula sheet. So you don't have to memorize these. They're all given to you. So on the next page, it says determine the surface area of the following right cylinder. So the word right just means that the base and the side are perpendicular to each other. All the ones that we work with in this course will be right cylinders. It asks us to write it to the nearest square centimeter, complete the solution in the box. So our dimensions originally are given in terms of feet. So we're going to find our surface area in feet, and then we'll convert it into centimeters squared. So remember, the formula for surface area of a cylinder is 2 pi r squared plus 2 pi rh. So it'll be 2 times pi times r, the radius, which we're actually not given. What is it, Brock? Paying attention, you'd know. The diameter is 10 feet, so what's the radius? Yes. And that number has to be squared. The formula says pi r squared plus 2 pi times r, the radius, which again is 5 feet, times h, the height, which is 21 feet. So we can square the 25, and we'll get 2 pi times 25 feet squared, plus, we can start to multiply some numbers together here. So, for example, 2 times 5 is 10, times 21 will be 210 pi feet squared. So we could do something else here. We could multiply the 2 and the 25 together and get 50 pi square feet plus 210 pi square feet. And because they're both terms are written as a multiple of pi, we can actually add these together. If you have 50 of something and you add 210 more, that would give you 260 of those things. 260 pi square feet. That's the exact answer for the surface area of that cylinder. Exact. We can then use our calculator to find out what it is as an approximation by going 260 times pi. So approximately 816.81 square feet, which we want to convert into centimeters squared. If you look on your formula sheet, you will see to go from feet to centimeters, you multiply by 30.48. 1 foot is 30.48 centimeters. So to convert it into centimeters squared, though, we'd have to multiply by 30.48 squared. Remember, we looked at this yesterday. So we'll take that number in our calculator, the entire number, and multiply by 30.48 squared. So it's a big number. 758, 845. 0.12, we'll say, centimeters squared. And again, it's approximate because we had to round off the answer. But we didn't do it till the very end. Okay? So again, you should have your formula sheet handy. You're going to be using it almost on every question now. This next question says determine the surface area of the following right rectangular prism. So the right again part means that the base and the height are perpendicular to each other. It's a rectangular prism because the base is a rectangle. And we saw that we can find the surface area by going 2 times length times width plus length times height plus width times height. It doesn't matter what order those three terms inside the brackets are written in. It doesn't matter. But the way I wrote it down, it matches exactly what's on the formula sheet. So it'll be 2 times length times width. So if we say that L the length is 4, W the width is 3, H the height is 2, length times width will be 4 meters times 3 meters plus length times height would be 4 meters by 2 meters. Width times height, 3 meters by 2 meters. So 4 times 3 will be 12, and you're also multiplying meters times meters, which gives you meters squared. 4 meters times 2 meters is 8 meters squared. 3 meters by 2 meters is 6 meters squared. If you add those up, you're going to get 26 meters squared times 2 would be 52 meters squared. There's the surface area of that rectangular prism. So again, what does that mean? It means that if you had small squares that measure 1 meter by 1 meter, it would take 52 of them to cover up that shape completely, the entire outside, including the bottom. Surface area means you can pick the object up and look at it from other angles. It's the area of all the faces added up. So there's just some more stuff that we've been talking about, what a cone is. Cone has a vertex, a slant height, and a radius. The lateral area is the area of the curve's outside part. The slant height is the shortest lateral distance from the edge of the base up to its highest point, which is where the vertex is. Right, so a cylinder also has lateral area as well. Right, so we've been talking about this stuff already. There's nothing new there. We've got a few more reminders there about what a sphere is. It's a round ball-shaped object, and the surface area is 4 pi r squared. So in many cases, you're just going to identify what the shape is, go to the formula sheet, find the right formula, and use it. A right cone, and all that means is that the base is perpendicular to the height, not the slant height, but the height, which all our cones will be. But it has a diameter of 27 centimeters, which means r, the radius, would be half of that. That'll be 13.5 centimeters. And the slant height is 40 centimeters, which we need because the formula for surface area of a cone is pi r squared for the circular bottom plus pi rs. And that's right off your formula sheet. The radius is 13.5 centimeters, which needs to be squared according to the formula. The other term is pi times, again, the radius, only this time it's not squared, times the slant height, which we are told is 40 centimeters. Now, most calculators will do order of operations. You can put this entire thing in your calculator all in one step. Pi, let me try that again, times 13.5, that needs to be squared, plus, again, pi times 13.5 times the slant height, which is 40. So to the nearest tenth, 2269.0 will be our approximate answer. Centimeters squared. There there's our surface area. All right. This next one says sketch a right cone with a diameter of 16 centimeters and a slant height of 12 centimeters. That's not going to work. There we go. So again, we have a diameter of 16 centimeters. So that's the entire length along the bottom there. And a slant height of 12 centimeters. If the diameter is 16 centimeters, that means our radius would be half of that. And the formula for surface area of a cone, right from the formula sheet, pi r squared plus pi rs. We also, at the start of the lesson, talked about a factored form, which is a little easier to work with. You can take out a common factor of pi r out of that expression. That's your first factor, your common factor. Your other factor is r plus s. So it'll be pi times the radius of 8 centimeters times r, which is 8, plus s, the slant height, which is 12 centimeters. So this would be pi times 8 centimeters times 20 centimeters, because 8 plus 12 is 20. If you multiply the 8 and 20 together, you'll get 160 times pi centimeters squared. That's the exact value for the surface area of that cylinder. Keen. If you want to go sleep, you can sleep down in the office. They have nice comfy chairs down there. Okay? So it doesn't tell us what to round it to, so we could leave it just like that. That's an exact value. That's the most accurate answer you could write down. Or you could go 160 times pi and round it to whatever decimal you wanted. 502.65 if I round to 2 decimal places. So there's the surface area of that cylinder, not cylinder, cone. All right, this next one is a rectangular pyramid. It's rectangular because the base is a rectangle. So you've got all the information you need. You've got the length and slant height 1. You've got the width and slant height 2. The formula on the formula sheet says that surface area is L times W, so that's the length and the width of the base, plus length times S sub 1 plus width times S sub 2. S sub 1 is the slant height that goes with L. So if we say that L is 20 and W is 16, S sub 1 goes with L, that would be, S sub 1 would be 17 centimeters. S sub 2 comes off of W, that would be 18 centimeters. But first we do length times width plus the length of 20 centimeters times slant height 1 of 17 centimeters plus our width of 16 centimeters times slant height 2 of 18 centimeters. So 20 times 16, that'll be 320 centimeters squared plus 20 times 17 would be 340 centimeters squared, plus 16 times 18, 288 centimeters squared. So now we will add these up. And give us a total surface area of 948. Because this formula does not involve pi, there's no rounding, because it doesn't involve pi. Now this next one on the bottom has a square base, which means that the length and width are the same, and because the length and width are the same, the slant heights are the same as well. So in this case here, if we start with the original formula, the length and width are both 10 centimeters, the slant heights are both 8.5 centimeters. So again, the base is 10 centimeters on both sides. Our length and width are both 10 centimeters. Plus, our length of 10 centimeters times the slant height of 8.5 centimeters. And the other term will be the same. The width is also 10.5. The slant height 2 is also 8.5. So 10 times 10 is 100 centimeters squared. 10 times 8.5 would be 85 centimeters squared. So it's going to be 100 plus 2 85s. You can go 100 plus 2 times 85. 270 is the answer. Right, so in this case here, the pyramid is a square-based pyramid. All four sides of the base are the same, so all four slant heights are the same as well. A satellite is wrapped with polyester film to protect it during transportation. How much film is required to cover the ECHO satellite that has a circumference of 98.5 meters? I'll express it to the nearest tenth of a meter. The formula for surface area of a sphere is 4 pi r squared. And r, the radius, is half the diameter. So that's where we would start. Divide the circumference by 2. Our radius is 47.75. Oh, I'm sorry. That's not diameter, that's circumference. So I apologize for that. The formula for circumference of a circle is 2 pi r. That's on your formula sheet. The circumference is 95.8 meters. Circumference is the distance all the way around the outside of the sphere. We use this then to find out what r is by dividing both sides by 2 pi. So if you do it like this, and we've talked about this before, you have to put the 2 pi in brackets in your calculator. You could do it in two separate steps, divide by 2 first, then by pi second, and then you don't have to use brackets. But if you do it in one step by dividing both sides by 2 pi, there's r, 15.25 approximately. But that's a number we're going to keep in our calculator. So now we can find surface area. It's 4 pi times the r value that we found, which is approximately 15.25 meters, and that number needs to be squared. So if we go to our calculator, we can square it right now, and then multiply by 4 pi. Notice you don't actually have to put a times in between the 4 and the pi. 4 pi means 4 times pi. So there's our answer. It says to the nearest tenth of a square meter, 2921.3 would be our answer, approximately. If we round to the nearest tenth. We're asked to find the surface area of a basketball with a diameter of 23.85. So now we can find the radius by dividing the diameter by 2. So 23.85 divided by 2 is 11.925 centimeters. And that's what we put in our surface area formula. That's what R is in 4 pi r squared. So again, we've got this in our calculator already. Let's just square it, and then we'll multiply by 4 pi. 1787 to the nearest hundredth, 0.01. Hundredth is 2 decimal places. 1787.01. So there's the surface area to the nearest hundredth, which is 2 decimal places. This next one, we want to determine a dimension when the surface area is known. We're given that the surface area of official 5-pin bowling balls can vary. It's between 459.96 centimeters squared up to 506.71 centimeters squared. What is the variation in the diameter? The formula for surface area of a sphere again is 4 pi r squared. So that's what we're going to use. The largest ball has a surface area of 506.71 centimeters squared. That is the surface area. And surface area equals 4 pi r squared. So we're going to solve for r. And then we'll double it to get the diameter. But we first have to figure out what r is. So our next step would be to divide both sides by 4 pi. And so like we talked about earlier, we need to use brackets. 506.71 divided by, in brackets, 4 pi. This is what r squared equals, 40.32 approximately. We're still in centimeters squared right now. This is what r squared is. To find r, then we take the square root of both sides. So not only are we taking the square root of the 40.32, but we're also taking the square root of r squared and centimeters squared. So the square root of this number would be 6.35 centimeters. And then d, the diameter, would be 12.7 centimeters. We multiply the radius by 2. So that is the diameter of the largest bowling ball. The smaller bowling ball has a surface area of 459.96. And so that equals 4 pi r squared. That's our formula for surface area of a sphere. So again, we would divide both sides by 4 pi to get the r squared by itself. So 459.96 divided by in brackets 4 pi. So r squared will equal 36.6 centimeters squared, which again, we will take the square root of both sides to get r. So 6.05 centimeters. And if we double that, we'll get the diameter. So approximately 12.1 centimeters. So there's your variation in your diameters. It'll go between 12.1 centimeters and 12.7 centimeters. There's the variations in the diameters. Example 5. This is known as a composite shape. It's two different shapes put together. A farm equipment manufacturer in Yorkton has decided to construct a grain bin using galvanized steel. How much steel is required to construct the grain bin? We'll do it to the nearest square foot. Do not include overlap of the steel sheets where they are fastened together. The other thing we won't include is the base, because the base is not made out of steel. It's either wood or it's cement. So this is an example where we have to be careful with what parts of the formula we're using. The bottom is a cylinder, but there is no circular bottom and circular top. Again, the bottom of the granary is made out of either wood or concrete. It's not steel. Also, we wouldn't have a top on this cylinder because if you dump the grain in from the top, it wouldn't get down to the bottom cylindrical part if the top was covered, the top of the cylinder. The formula for surface area of a cylinder is 2 pi r squared plus 2 pi r h. But in this case, we will not use the 2 pi r squared part at all, because again, that represents the circular top and bottom of the cylinder, which would not be steel in this case. The bottom would either be wood or concrete, and there'd be nothing on the top of the cylinder. So for the first part, we're just going to use the 2 pi RH piece of the formula. So the D, the diameter, is 19 feet. So R, the radius, would be half of that. That would be 9.5 feet. Times H, the height of the cylinder, is 21 feet. So we're going to multiply 2 times pi times 9.5 times 21. 2 pi times 9.5 times 21. Gives us 1233.5 approximately. 1253 square feet. Surface area 2 comes from the top piece of the grain bin, which is a cone. The formula for surface area of a cone is pi r squared plus pi rs. But we wouldn't use the pi r squared part because that represents the circular base of the cone, which this cone doesn't have. Otherwise, the grain couldn't get down into the very bottom. Only the pi rs part, but in this case, we don't have S slant height. We need to figure out what S the slant height is. And we can do that because we've got a right triangle here. The slant height would be the hypotenuse of that right triangle. The base of the right triangle would be the radius of the grain bin, which is 9.5 feet. The height of the right triangle will be the difference between 25 and 21. 21 is the height of the cylinder only. 25 is the height of the entire structure. The difference, or 4 feet, would be the height of the cone. So this is our next step. We need to find the slant height, which would be the hypotenuse of that right triangle. And we can do that using Pythagorean theorem. A squared plus b squared will equal c squared. 4 squared plus 9.5 squared will equal c squared. Let me store this previous answer into memory slot A so I can get it easily back when I need it. So now we'll calculate our slant height, which is the hypotenuse of that right triangle, by going 4 squared plus 9.5 squared. That'll be 106.25. That's what c squared equals. And then we'll take the square root of both sides to get c by itself, approximately 10.3. And that'll be feet. So that's what the slant height is here. Pi times our radius of 9.5 feet times our slant height, of 10.3 feet. So I'm going to multiply that by 9.5 and pi. So the second piece, the cone on the top, the lateral area is 307.6 approximately square feet. So now I need to add these two together. The total surface area will be found by adding the two together. So I'll add this to memory slot A. It's a total of 1561.13 square feet. It says to the nearest hundredth, 2 decimal places, so that's what we did. Okay? So sometimes you're going to be working with composite shapes where two shapes are put together. Also in this case, we had to do some adjustments to the formulas because the cylinder didn't have a top or a bottom and the cone didn't have a bottom. So we only used part of the surface area formula, which is why it's important to understand where those different pieces come from. Now, we're not going to do this next one, but let's just talk about it real quick. If you want the surface area, it's like a dumbbell, right? And the handle is a cylinder, but the top and bottom are invisible. You can't see them, right? Where the left side of the cylinder connects to the weight, you can't see it. So you wouldn't count that in the surface area. Same thing with the one on the right side. So for the handle, you would just use the 2 pi RH part of the cylinder. Also, the weights themselves are both cylinders, but the piece where the handle touches, you wouldn't be able to see either. So you'd have to subtract those two pieces where the handle meets the weight. You'd have to subtract those two areas from the surface area of the two weights. Okay, so that's what you would have to do. We're going to spend 2 more days on this chapter. So that'll be Thursday and Friday. The following Monday, you're going to have your quiz on chapter 2. And then we're going to get into chapter 3, trigonometry. Okay? So you should do these questions for practice. I will post the solutions to Google Classroom so you can check your work, but you should do it. Some of you did very poorly on that quiz yesterday, which means that you probably haven't been doing your assignments, haven't been doing the practice. And you also probably didn't spend much time studying either, which is important for these quizzes. Okay? We'll do these questions, check your answers. We'll go through the chapter 2 quiz, or chapter 1 quiz, I should say, here, once everyone has written it, hopefully in the next couple days. Also, don't forget that everything is due Friday, June 9th. All your assignments have to be handed in. I will not accept anything after that. They will go in as zeros. So if you don't think I'm serious, look at my face. This is me being serious. You'll get zeros on anything not handed in after Friday the 9th.